So for all this time, we've been always looking at equations in terms of y equals to mx plus b. But there's another form that you have to know, and it's called the general form. And how this works is really, really pretty. This works out as ax plus by plus c, and that always has to equal to 0. So what you have to do is you have to manipulate this equation so it always is 0 equals to blah. Okay, so you're going to have your x in there, you're going to have your y in there, and you're going to have some sort of constant value in there. These all become very, very, very important, and it leads to a different style of graphing. Okay, but there's also a couple things that you have to know. First things first, a must be positive, and all of these values, every single one of them, a, b, and c, must be whole numbers or integers, okay, or integers. And what they mean by this, guess what? No fractions, no decimals. That's where the challenge comes in. So moving right along, let me show you a couple things here. It says the general form of a linear equation is, as I just wrote, ax plus by plus c. Your a is always positive, and every one of those values are integers. In other words, there's no fractions, no decimals, okay? A is always going to be a whole number, and whole numbers, we know, are positive, right? So we can convert this anyway by using, algebra, yahoo! So why is this important? Okay, the reason why this is important is it sets up a brand new way of graphing, which I just can't wait to show you. And it's based on this, the x-intercepts and the y-intercepts. Oh my goodness. So taking a look at a few things here, let me show you something that's really, really cool. You don't need to always graph y equals mx plus b. As long as you have 2 points, that's all that matters. Think about it. When I was doing y equals mx plus b, look, there's my y-intercept. Then I'd say, oh, it's a rise of -2 and a run of, let's say, 4, and I put another point. Boom. Well, look, I drew a line using 2 points. Now I'm going to draw a line using 2 points, but if you think about it, it's going to be the x-intercept and the y-intercept. Can I do that? Well, yeah, actually you can. Let me prove it. Here's example 1. Notice that x and y intercepts is the way we're going to do this, okay? And it asks you right off the bat, what are the x and y intercepts from this wonderful equation? And then we're going to use these intercepts to graph. Well, how do you do this? Super, super easy. Check this out. If it's an x-intercept, you know y equals to 0. So check this out. If x-intercept, look at this equation, 2x plus 3y plus 6 equals to 0. If it's a y equals to 0, no matter what you substitute in here or what the value is up front, as long as you substitute in a 0, check this out. That just gets rid of this because any number times 0 is 0, leaving you with 2x plus 6 equals to 0. And look at this, 2x equals to minus 6, divide by 2, x equals to minus 3. You now have a point, minus 3, comma 0. And I can go over to my graph here and go, oh, there's minus 3, comma 0. There's my x-intercept. Do the exact same thing now to my y-intercept, which we know means x equals to 0. And check this out. Look. If x equals to 0, and you've got your original question here, right? Look how easy this is. If x is 0, that means this guy is gone because any number times 0 is 0, leaving you with 3y plus 6 equals to 0. Bring the 6 over, so 3y equals to minus 6. Divide by 3, you got y equals to minus 2. So you've got another point here of 0 minus 2. So check this out. 0 minus 2 is right there, and guess what? There is your graph. So I'm giving you the x coordinate and the y coordinate, and holy smokes, you can do so much with the general form.